Hey there! In today's video, I'm going to be taking you through how I made a variant of Doodle Jump in Unity. You can find a link to the source code and all of the project files in the description down below. It's available to all of my Patreon supporters. Thanks a bunch to those of you who support me on Patreon. It means the world and it is keeping me going. One more thing, there is currently a Unity sale going on, the Unity Summer Sale, and you can get assets on sale for up to like 90%. It's wild. There'll be an affiliate link in the description down below for that as well, so do check it out. Thanks to those of you who use those affiliate links, they really do help me out. Anyway, let's jump right into the video. Okay, so I've already created a project, but I'm going to show you how I did that. I'm using Unity Hub version 3.13.0, so if yours looks a bit different, it might just be because you're on a different Unity Hub version. I'm going to click the new project button, and for the editor version, I'm going to select the latest one I have installed. Then I'll select the universal 2D option. And then in the project name, I'm just going to go down to create a new local project called, and then I'm going to change this. In my case, I changed it to Jumpy Wumpy. And I saved it in my tutorials folder and I hit the create project button. Okay, so after creating your project, the first things I like to do is to split the scene and the game view so that we can see what's going on in both. Now, because we're going to be working on a mobile game, we want to add the 9:16 aspect ratio. Hello, doggy. What's going on? Hello. Yes, I'm speaking to the camera. Thank you. Okay, bye. I love you. Okay. Sorry about that. Let's move that up there. Okay. Yeah. Okay. So the first thing because we're making a mobile game and we want it to be in the portrait resolution, we need to add the 9:16 aspect ratio. So I've added it before, but if you have not got that, then you can just click the add button and you can change the type to aspect ratio and then type in 9:16, and this will create your portrait mode view for your mobile game. All right. The next thing I would do is I would rename this scene to main scene, because this will be the main scene that we do everything from. Then, because we're going to be making a Doodle Jump like game, the first thing we'll do is we will add a 2D sprite that is a square, and this we will call platform. Okay, and then we'll move this down to like somewhere here and just fiddle with its width and height a little bit so we get something we like. And to it, I'm also just going to add a box collider 2D so that we can actually collide with it. Then I'm going to add a square, and this is going to be our player. Also, let's change the color of these things. So the platform, I'll make like this brownish color. And the player, I will make a greenish color. And then we will just bring in the width of the player a bit and maybe expand his height, and then we'll move him over here. And to him, we're also going to add a box collider 2D, and we're going to add a rigid body 2D, and we're going to freeze the rotation in the rigid body 2D. So now this means that our player will be affected by physics. So if we hit the play button here, we expect that he will fall down, and he won't fall over or anything because we've frozen the rotation on the Z-axis, so he can't move, he can't rotate left and right. Cool, so Doodle Jump done. All right, next step. So now we're gonna wanna make our player jump when they collide with this platform. So I'm gonna go in here and I'm gonna create a new folder. Okay, let's redo that because my face is in the way. I'm gonna put my face like in the middle somewhere so that it's out of the way of most things. All right, so we're gonna say create a new folder and we're gonna call it scripts. And then inside of the scripts folder, we're going to create a new mono behavior script and we'll call this player controller. All right. Okie dokie, and this is what our player controller script is going to look like for now. All we want to do is we want to make the player just jump up and down when they collide with the platform as a start. So to do that, we'll define a private float jump force that will set to a default of 10 for now. We've serialized this so that we can change it in the Unity editor without having to come back and change a bunch of code each time we need to make a change to the value. Then we'll define a private rigid body 2D rigid body to get a reference to the rigid body component we added to our player just a moment ago. Then in the start method, we'll actually get that component from our player. Because we're going to be attaching this player controller script to our player, it should be able to get the rigid body without any hassles. Then we're going to add unities on collision enter 2D function. And in here, we're just going to say to the rigid body, add a force in the upward direction and multiply it by our jump force. And we'll use the impulse mode for the force mode so that we only apply this force once. Cool. We can save that script and then head back to Unity. Now, nothing's going to happen because we need to actually attach the player controller script to our player game object. So I'll just drag in the player controller to the player. And now when we hit the play button, boing, our guy jumps very high. But as we can see, his jump is very floaty and it doesn't look great. So what we can do to make that feel a bit better is we can affect the rigid body, or we can change some properties in the rigid body that define how physics affect it. So for example, we can change the gravity scale to something like 1.3. So now it will fall faster. And then we can also add linear damping, which is a frictional force. Kind of like if you imagine swimming through water, the force that the water applies on you as you try to swim is similar to what linear damping does. So as we can see, it's harder for the guy to reach his peak. And we can fiddle with these values till we get something we like. I think a value of 1.3 for the damping and the gravity scale seem pretty good. And then we can increase the jump force to about 12. And that'll be good. But remember, when you stop your game, then you'll lose all your values. So you just have to come in here and make those changes again. Okay, so the next thing we want to do is we want to add some left and right inputs. So to get that right, what we're going to do is, firstly, we're going to add a movement speed. So this will just be something we multiply by the input that we're going to get to in a moment. We're going to use Unity's new input system here, and using that is really easy. So to get started with that, we're gonna need to add a reference to Unity's input system. So you just type using Unity engine.input system, and then here we're gonna add a variable of type input action, and we'll call it move input action. And then in the start method, we're going to call the input system.actions.find action, and we're going to look for the move action. This is defined by default in Unity projects. So if we come to, okay, Unity's just doing some stuff. If we come to file, I think it's in edit, project settings, and we go to the input system package. So if we click on the input system package, then we can have a look at all of the actions that Unity have defined for us by default. So this is really cool because what it lets us do is not care about where this input is coming from, whether it's a controller or tilt controls on our phone or a keyboard. We don't care. We just look in our code for the move input action and we'll get the value out. It's really cool. All right, so now to actually read the value out, because we're going to be affecting the physics, we want to make changes in the fixed update function. So we'll just reference Unity's fixed update function. And in here, we'll get the move input vector. So we're going to get a vector 2 out of the move input action. And we're just going to call move input action.read value, and it will return a value of type vector 2. And then to our rigid body, we can just modify the linear velocity. Now, if you're using a version of Unity before Unity 6, this is just going to be rigid body.velocity. I see a comment every time about this. So just keep in mind that if you're on Unity 6, we're using the linear velocity, and ChatGPT won't know about it. Anyway, so to update this velocity, we can say rigid body.linear velocity equals new vector 2. And because we just want to apply a change on the x-axis, we're going to say move input. So give me the move input value, but only give me the x of that move input vector and multiply it by our movement speed that we defined earlier. And then just maintain the same linear velocity dot y value on the y-axis because we don't want to affect that at all. And now if we head back to Unity and we hit the play button, if I press W and D, our player moves from left to right, which is awesome. Cool, next step. Okay, so the next thing I want to do is I want to create a prefab out of our platform because I want to start making changes to it. So prefabs are really great because we can make changes in one place and they will apply to all of the references to that prefab. So to get started, I'm going to create a new folder and I'm going to call it prefabs. And inside of the prefabs folder, I'm just going to drag in our platform. Now, this is awesome because if I duplicate my platform and move it up to here, and then I double click my platform prefab, I can come in here and I can make changes. And then as we can see on the game view, that changes all of the platforms that reference the same prefab. So that is cool. I'm just going to zero out all of these things. Positions won't be affected by prefabs, by the way. And cool. So now if we put our player here, we're going to notice our first major issue. And this is if we jump, we just collide with the bottom of the platform. But as you know, if you've ever played Doodle Jump, then the player should traverse through the platform. And because this is such a common mechanic in platformers, Unity has us covered. So to fix this, what we can do is we can come to our platform and we can add something called a platform effector 2D. And then to make this work, we need to, in our box collider, we need to say used by effector. We need to tick that box. And then what you'll see is in the scene view, we get this arc. What it's telling us is that if anything collides with this platform whilst it's within this arc, the collision will register. But if it is outside of the arc, the collision will not register. If you hear my dog barking outside, I'm sorry. Well, not really. Dogs bark. Anyway, so because we don't want our player to collide with the side of this platform, we can change the surface arc to something quite small, like 25, for example. So now the player has to be within this range for them to collide with the platform at all. So let's save that in our prefab and then let's test it out over here. Whoa! So as we can see, it passes through the platform, which is exactly what we want. But there's two issues right now. So for one, it collides with what seems like halfway through the platform. And the second issue is it does pass through, but then as soon as it gets into that arc, then it applies the jump velocity again. So to fix this, we can do two things. So the first thing we're going to do is we're going to add a variable that keeps track of a platform height offset. So if we look at our platform prefab, we can see that the center point of this, or the origin of our platform, is in the middle. So that's why it doesn't matter what logic we add, it will still think that the collision will occur halfway at this point of the platform. So we can just add, so that variable, I've just added a offset so that we can tell it to move up a little bit and only register the collision from there. So to do that, we'll add a platform height offset. And in our onCollision enter 2D function, we're going to make a quick change that just says if the transform, so if our player is above our platform, and we'll add the platform height offset to that. So our player needs to be above the platform plus that platform height offset for the collision to register. And now what this will do is this will help us with both of our issues. Okay, so that's cool for now. Okay, so the next thing we want to do to progress our game is we want to now start spawning our platforms procedurally. So to do that, I've gone ahead and created a script called platform spawner. So I'll just open this in Writer and explain what's going on here. So the first thing we're going to need to do is we're going to want a reference to our platform prefab that we created earlier. All right, then we're going to need a variable for the number of platforms to spawn. Now, how this spawner, how I've written the spawner, there's many ways to do this, but the way that I decided to do it from here is I keep track of what is the last spawned platform. And when the camera gets far enough away from the last spawned platform, then we spawn a bunch of new platforms. And this number of platforms to spawn is the number of platforms that we spawn when we reach that threshold. The next variable we're going to need is the first platform. So this one will always be a standard platform where it's not going to be procedurally added. Then we're going to need a max distance from the camera before we spawn anything. Then we'll need a minimum and a maximum distance from the previous platform. So this will determine how far apart each platform can be from the previous one. And then an X spawn range to determine where on the X axis we spawn our platforms. Okay, and then in our start method, we're going to assign the last spawned platform to the first platform. And then we're going to call our spawn platforms function, which is a new function we're going to create. And in the spawn platforms function, we're going to loop through from 0 to the number of platforms that we want to spawn. And then we're just going to check a couple of things. Firstly, we're going to get the distance to the next platform. So to do that, we can just use a random range, and we can use our minimum distance from the previous platform variable that we created and the maximum distance from the previous platform. So this will give us a new distance between platforms, between the last spawned and the newly spawned platform. And then in X position, we can also just randomly generate a new X position between our negative and positive spawn range from the variable we defined earlier. And then we'll actually get our spawn position, which will be a new vector 2 using the X position. And then we're just going to want to add our distance to the next platform from we're going to want to add the distance to the next platform to the last spawned platform's Y position. So if the platform is currently at 10 and we've determined the distance to the next platform is 3 above that, then we just need to add 3 to 10 to get the new spawn position. And then finally, we can instantiate our new platform and assign last spawn platform to that. Then in our update function, what we want to do is we want to check if our camera's Y position is greater than our last spawned platform plus the max distance that that the last platform can be from the camera, then we want to spawn more platforms. So that should be all we need to do here. And then in our scene view, what we need to do is we're going to create a new empty game object. We'll call it game. So this will be the thing that handles all of our game information, like spawning of platforms. And then we'll drag in our platform spawner script. And into this, we just need to add our platform prefab. And we need to add in the first platform, which is this one. And then we can delete this platform. And we should be able to test this out. Boom. And there we go. We spawn platforms, but as we can see, our camera currently does not move. So we'll sort that out in the next step. Oh, and just a note here, as we can see, the player spawns in and is behind all of the platforms. So to fix that, we can just go to our player. And in the sprite renderer, we can change the order in layer to 1. So it will render last and above all of, or seem to be above all of the other platforms. Boop, boop, boop. And there we go. All right. So now to make our camera move, we're going to need a camera controller script, which I've created here. Let's open this up in Writer so we can see the camera controller. All right. So this is a pretty simple script. All we're going to do is we're going to get a reference to the player's transform. And then in late update, we want to do this in late update because the player does things based on physics, which happens in fixed update. So we only want to update our camera after all of the physics operations have happened. So we'll do this in late update. And all we're going to do is we're going to check if the camera is currently lower than the player's position, then we just want to update the camera's position. We don't want to change anything on the x-axis, so we'll just use the camera's current x position. But then we want to update the camera to be at the same position as the player's y position, and then we'll just keep the same z position of the camera. And then back in Unity, we can just attach our camera controller script to our camera game object, our main camera game object, and hit save. And that doesn't work because we need to assign our player to our main camera's property. There we go. So now if we hit the play button, then we can see we move around and our camera moves up with the player. And we can see that we're spawning in more platforms, which means our platform spawner is working quite well. A cool little hint, if you want to track what's going on here, you can hit, if you select the player in your scene view, then you can hit Shift F and it will track the player, or track whatever game object, and then you can just zoom out and we can see what is happening. So this looks pretty cool. But the main issue now is that we are spawning a buttload of platforms without deleting them when we need to. Obviously, the ideal solution would be to create an object pooler, but for the purposes of a beginner tutorial, I'm going to stick to just creating and deleting. If you guys would like to see the implementation of an object pooler, then let me know. I can make that happen too. Okay, so next step is to add a platform handling script that will delete our platforms when they get far enough away from the camera. So I've gone ahead and created a script called platform. So in here, we've just got a variable in our platform script that determines the maximum distance that this platform can be from the camera before it needs to be deleted. And then we just check if the camera's current position is greater than our platform's position plus that max distance. And then we destroy our platform game object. Now we just need to go into our platform prefab and assign the platform script, which I've done there. And now if we hit the play button, then we will see that any platform that is spawned will now have our platform script. And if we just zoom into our player, we'll notice that as we get higher up, our platforms disappear, which is great. Cool. Now for the next step. All right, so the next thing I want to do is I want to add the ability for the player to die. So to do that, we'll use the distance from the camera again, because remember the camera doesn't track the player as it's moving down, only as it's moving up. So what we can do is we can just add a variable here that tracks the max distance that the player can be from the camera before they're considered dead. And then in our update function, we'll just check if the transform.position.y, so our player's current y position, plus the maximum distance from the camera that the player can be, is less than or equal to the camera's current position, then we'll just deactivate our player game object. So now we've currently got this set to 5, and let's take a look at what happens. Righty, so we play and then we fall, boom, and then our player is deactivated, which is great. Okay, so now that our player dies, it would be a good idea to have some UI that we can use to start the game and restart the game once the player is dead. So to do this, we're going to add a UI and a canvas. And to our canvas, we're going to create a UI panel. As you can see, panels are useful because they cover up the whole screen. And we will call this our menu panel. Then we're going to create a UI text mesh pro. This will be for the name of the game. Oops, so we need to import text mesh pro essentials. That's cool. Okay, we can close that and then we'll just call this name. All right, I'm just going to change the background of our panel to something. I don't know. I'll probably fiddle with this. So I get something I like. But anyway, if you hold Option, or I think it's Windows button or Control on Windows, and you hold the Shift key, this gives you some good anchoring options. So we can anchor our text right to the top of the screen, and then we can center it, bold it, and center it again, and we can call it Jumpy 1P. And maybe we'll move it down a little bit so we can just decrease this Y value. Maybe something like -100, and that looks quite good. Maybe increase the font size to 40. Then we're also going to need a start button. So let's create a UI button, text mesh pro. We'll call this button_start. And inside of it, we're just going to create, we're going to change the text to say start. Cool. So that's our canvas. Now for the next step, we're going to need to add a script that we can use to attach to our canvas and handle all of our UI operations. I'm just going to center some stuff for sanity's sake. So we'll just move that, and then we'll also just move the player to the center. And I'm also just going to deactivate the player by default. So when the game starts, the player will be deactivated. So I've just neatened up some things and added some more detailed naming. So we've got our menu panel, our game name, and our button_start game. I've also gone ahead and created a UI manager script. So let's take a look at what that does. So the UI manager script is very simple. It just has a reference to our menu panel. It has a reference to our player, and it has a public void start game function that our button click will call. So in there, we're just going to set our menu panel to inactive, so set active false, and we're going to set our player to active, so player.setActive to true. Then we're just going to drag in the UI manager into our canvas, and then we're going to drag in our menu panel into the menu panel, and then we're going to drag in the player into the player. And then the last thing we need to do is on our start game button, we need to add an on-click event handler, and we're going to drag in our canvas, and we're going to go to our UI manager script, and we're going to call the start game function. And now when we hit the play button and we click the start button, then our player is activated and our game starts to do things. Now, the next thing we're probably going to want to do is add the ability to handle when our player dies. Then we want to show our menu panel again. I've updated our UI manager script for a couple of things. Firstly, we need a player start position. So when the game starts up, because if our player dies and then we restart, we need to reset their position. So I've just added a player start position vector2 variable. And then in the update function, I've added a check to see if the player is active and if the menu is currently inactive. So if the player dies, basically, then we're going to set the player's active state to false, and our menu panel will also be inactive at that point in time. So then we can just activate our menu panel again. And I've also updated our start game function to just reset the position of the camera. So it will reset the position of the camera to 0, and then it will set the player's transform to what we define as the player's start position. So now when we start our game, we hit the start button, then our player is there. And if we die, then the menu panel pops up automatically. And if we hit start, oh, we've got a bug because our initial starting platform does not spawn back, which is a problem. Okay, so to fix that, in our platform script, I've added a variable that determines if the platform is the starting platform. If it is, we just set it to inactive instead of destroying it like we do with all of the other platforms. And then in our UI manager, I added a reference to the starting platform. And when we start our game, then I just set the starting platform to active again. You can use a game object. I just use the platform component directly because I think we might need to use it in future for other things. So now on our starting platform, which we've now renamed to starting platform. We just need to make sure that the is starting platform value is ticked. Now remember that on the default other platform prefabs, that will be false, which is exactly what we want. Okay, so now when our game starts, we'll see that when the starting platform moves out of range of the camera, it just disables it and it's still there. But when we die, I don't remember assigning this. So let's just see. Okay, we have assigned the starting platform to the UI manager's starting platform. So when we hit start, then it will reactivate that platform for us. But as we can see, we have some issues. We haven't deleted the old platforms that spawned in the previous run of the game. So now our last spawn platform is not working with our platform spawner as we expect. So let's fix that up. Okay, so we're going to make some changes to our platform spawner script to make sure that we handle spawning platforms correctly. Okay, so the first thing we're going to do is we're going to add two new variables. One that is a list of type GameObject. If you're getting an issue there, you might need to add, you will need to add a using systems.collections.generic reference. And then we're going to use a Boolean to determine if we can spawn platforms. All right. Now, in our let update function where we check if we can spawn platforms, the first thing we're going to do is we're going to add an if statement to check if we can spawn platforms. If we cannot, we're just going to return out of our let update function. Okay. Then we're going to add a function called handle respawn, and this will be called outside of this platform spawner, and this will set our can spawn platforms value to true. And then we're going to add a function for handling death. So once the player dies, then we want to handle the death. And what we're going to do there is we're going to loop through all of the game objects that are in the spawn platforms list. And we're going to check if they're already null, because remember that platforms can also destroy themselves. And if they're not null, then we're just going to destroy the platform. Finally, we're just going to clear out our list so that it's empty and doesn't have a bunch of empty entries in it. And then we're going to set our last spawn platform back to the first platform. And then we're going to set can spawn platforms to false because the player is dead. Then finally, what we need to do is after we instantiate our platform in our spawn platforms, we want to add it to our spawn platforms list. Okay. And then we're going to want to handle this in our player controller. So in our player controller, we're going to need to add a reference to our platform spawner. All right. And then in here, where we handle the death, so where we set our player to inactive in our update loop, we're going to call our platform spawners handle death method. And then on enable, so this will be a Unity function, and when our UI restarts our game and sets our player back to enabled, then we're going to call our platform spawner.handle respawn, which will allow our platform spawner to spawn obstacles again, or spawn platforms again rather. And then in Unity, we're just going to need to make some changes on our player. We're going to need to assign our platform spawner, which exists in our game, so we can just drag that in there. And that should be all we need to do. So now if we hit the play button and we start it and spawn some stuff, and then we die, boop, and then we see all of our objects have now been destroyed, which is good. And when we hit start, then everything spawns as it should. Cool. All right, so the next thing we want to do is we want to handle some runtime information, like the player's score, for example. Okay, so to do that, to our canvas, we can add a new UI panel. We'll call this the runtime panel. We'll move it above the menu panel. I'm just going to hide the menu panel for now. And here we'll set the runtime panel to completely transparent, but inside of it we'll add a UI text mesh pro, and we'll call this score, and we'll just anchor this to the top right hand corner with command or control and shift, and then clicking this top right hand corner button. I'm also just gonna center all of our text values and set this to a default value of a number. And if you want to, you can shift it over as much as you want, but I think a value of 0 is fine there. Well, ideally, actually, instead of centering it, we can move it over to the side. So then as this number increases, then it will just keep moving over that way. Hopefully the player doesn't get to that score, but we could also just stretch it all the way across, because now we've anchored it to the right. We've aligned the text to the right, and then we can move this over on the right. Maybe about 30 is a good value. So if we wanted to see what this would look like in the game view, we can just hide that. So then our player score will just appear in the top right hand corner once we've bound it and scripted it. Okay, so to handle this in the scripting, let's open up our UI manager script. And to it, let's add a new serialized field, private, text mesh pro UGUI, and we'll call it current score text. You'll need to add using TM Pro here so that Unity can find the reference. We'll also create a private variable called current score. Okay, so in the update function, what we're going to do here is we're just going to check, is the player active? And then if the player's Y position is greater than the current score, then we want to set the current score to the player's Y position. And then we'll set the current score text. So this is the text mesh pro object. So current score text.text, and we'll set that to the current score.toString, and we'll use formatting of 0 here. So this will remove any decimal points in the string value that we render out to the screen. So we can save that. And then in our Unity scene, we just need to come in here and assign our score text to the current score text property. So now we can re-enable our menu panel, and when we hit start and we click the start button, then we'll see our player's score increases as we move up in height. Alrighty, okay, the next thing we're gonna do is let's add a high score tracker. So to do that, in our menu panel, we'll create a new UI text mesh pro. We'll call this label underscore high score. So this is going to be our high score label, and we will stretch it out, bold it, center it, type high score, and we'll move it up a bit to like here. Then I'm going to add another UI text mesh pro, and this is going to be our high score text. This is going to be the actual value that we bind to this, so I'll do much of the same thing, bold it out, center it, and we will move this up to here. All right, so with our canvas setup, we're going to need to make some changes to our UI manager script to keep track of the high score. Okay, so to do that, in our UI manager, we're going to add a serialized private text mesh pro UGUI variable called high score text. We're also going to add a variable that keeps track of our high score value. And then in our update loop, we're just going to check, we're just going to add an additional check in here that says if the current score is greater than the current high score, then set the high score to the current score and set the high score.text to the high score.toString with the 0 decimal places formatting as well. And that should be all we need to do. And obviously assign the values. So if we come to our canvas, then we just want to assign our high score to our high score text field. And now when we hit the play button, boop, 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 and if we die, then we see we have a high score of 5. Now, when we hit the play button, we still have this bug where the player starts on the current score. So let's fix that real quick. We just need to reset the value on death. So in our UI manager, we'll just scroll down to the start game function. And when the player hits the start game button will just set the current score to 0 right at the start of the game. And now if we play, let's get some score, boop, and then let's die. And then when we start, oh, that did not fix it. Why? Okay, this is because we didn't actually set the text mesh pro object to be 0 as well. So we can say current score.text equals current score dot toString. So basically just set the current score text value back to 0. And now if we go ahead and hit the play button, get some score, die, and start again, then our current score will be reset to 0. Cool. Okay, so next things next, let's see if we can add some enemies to our game. I'm just going to hide our canvas for now. And then I'm going to create a 2D object sprite circle. And we'll call this enemy. And we'll just set this to 0 and 0, and it will pop up on our screen. And maybe we can just increase the scale a tiny bit. And then I'm also going to add a circle collider 2D to this. Cool. So now this will act as our enemy, and we need to add some logic to handle what happens when the player collides with it. So we're going to want to handle these collisions in our player controller, but we need to think about how to differentiate between a platform colliding with a platform and colliding with an enemy. So to do that, we can make use of something called tags. So up here, we've got our tags list, and we can come down to the add tags option, and then we can add 2 new tags, one for our platform and one for our enemy. And now in our prefab, let's assign our platform tag to our platform. And then in our enemy game object, let's assign the enemy tag. Okay, so I'm going to open up our player controller script, and in here we're going to change a couple of things. First things first, I want to create a die function, right? Because we're going to be using our die from a couple of places now. If you think about when the player collides with an enemy, then we're going to want to call a die function. So instead of manually doing everything that would happen when the player dies in the update function like we used to, we'll separate it out into its own function called die. And in here, we'll just do the same thing. We'll call the handle death on the platform spawner, and we'll deactivate the current game object. And then in our onCollision enter, what we want to do now is we just want to check which tag the game object we're colliding with has and whether that matches what we're looking for. So to do that, for our platform, we can call other.transform. We don't need transform. We can just do other.gameObject rather. .compare tag platform. And this will now check if we're colliding with a object that has the platform tag assigned. And if it does, then we'll just do our basic jumping logic. But if the other game object has the enemy tag, then we want to call the die function. And just like that, we have enemies. So if we go back to our Unity project, we can hit the play button. And now when we start, if we collide with an enemy, then the menu pops up, which is exactly what we want. The next thing we want to try add in here is the ability for the player to kill an enemy. Okay, so let's open up our player controller again. And in here, what I want to do firstly is I want to separate our jump logic that we previously had into a jump function. So in our jump function, all we're going to do is we're going to do the same thing, rigidbody.addForce vector2 up. And the reason for this is because now in our original logic where we handle our platform, we can just call the jump function. But then in our enemy function, what we can do is we can check if our player is currently above the enemy's position. And if we are falling or at a 0 linear velocity, then we can destroy the enemy and we can call the jump function. And if that is not the case, so if the player is below the enemy, so colliding with it on the way up, then we'll call the die function. This way we have a nice separation of what everything is doing, and it's quite easy to understand by just reading the code. Okay, and now if we hit the start button, Oh, I'm not going to be able to get there, am I? Ugh. Oh, I got there just. Okay, cool. So that works pretty well. And now the next thing we want to do is we want to look at spawning in enemies procedurally. Okay, so to handle enemy spawning in procedurally, what I'm going to do firstly is I'm just going to create an enemy prefab. So I'm just going to drag the enemy into our prefabs folder. Okay, then we're going to add an enemy spawner script. So we'll just go add a new enemy spawner script. All right, and our enemy spawner script is going to look pretty similar to our platform spawner. So we're going to need a couple of things. Firstly, we're going to want a reference to the enemy prefab so that we can spawn new enemies in. Then we're going to want a reference to our player. Next, we'll need a Y interval that we're going to be spawning enemies at. So we'll check the height of our player, and this says every 10 we're going to spawn in a new enemy. And then we just want an offset. So when the player reaches 10, then we want to offset where the enemy is spawned to. So like further up, maybe. So at this point, once the player reaches 10, then the enemy will spawn at 15 on the y-axis. So that way it will spawn off screen. And then a random x position, which we'll just randomize between negative and positive of this value. Then we'll want a list of spawned enemies so that when we die, we can delete all of the unused enemies. Then we're going to want a next spawn height so that we can track where we currently are in the spawning situation. And when we start, we're going to set the next spawn height to the player's current position and we're going to add the spawn enemy Y interval to that. So straight off the bat, we're going to spawn in an enemy 10 above the player. Then in our update function, we're just going to check if the player is greater than the next spawn height. Then we want to add to our spawned enemies list in instantiation of our enemy prefab, and it's going to be spawned on the x-axis between a random range of the negative x range and the positive x range, and it's going to be the next spawn height plus the offset that we added earlier. And then we'll set the next spawn height. Sorry, we're going to add the spawn enemies Y interval to our next spawn height here to get the next spawn height. And then here we're just going to check if the player is alive or not. So if the player is not alive, so if not player is active, and if the spawned enemies, if we have more than 0 spawned enemies, then we just want to go destroy all of our current enemies in the list. So to do that, we'll just loop through each game object in the spawned enemies list, and if it's not already been destroyed, then we will destroy it. Then the next thing we're going to want to do is we just want to add our enemy spawner to our game object, which if you recall is just our game handler. And then inside of that, we're going to drag in our enemy prefab and our player. We'll just drag that in there. And now if we hit the play button, then we can see our enemies spawn in eventually. Boop. Okay, so now I think we're at a good point to swap out the gray boxed assets for some real art. Well, I mean, we can call it real art, but this is the sprite sheet that I created. Very, very beautiful, I know. So what we're going to do is I've just exported this as a PNG, and I'll bring that into the project now. Okay, so I've just brought this in, and then in here, so you click your sprite sheet, and then you just make sure that your texture type is set to sprite 2D and UI. Sprite mode is multiple, and then if you open up your sprite editor, you'll be able to click on each of the little sprites. So in here, I've just gone ahead and renamed each of the sprites to player, platform, background, enemy, and bullet, which we won't be using at this point. But if you want to try it out, go ahead. And then you just got to save those changes. Okay, and then now in our platform prefab, we can start with this. And we can go ahead and we can change the square out with our platform sprite that we created. And then we'll just reset the scales of all of this to 1. Cool. And then our enemy, we can swap our enemy out with our enemy sprite. And again, we'll just reset the scales to 1. Can fiddle with the collider if we want to just make it fit the player, the enemy a bit better. Bring this down. You generally don't want to make, you want to make the collider be inside of the enemy so that it gives the player a bit of leeway and it doesn't feel unfair. Boop. Okay, so we're basically back to where we started with that collider, but that's all right. And we can just save that. And then our player, we want to change the player sprite to our player sprite, and we can just re-enable him so that we can see what he looks like. Let's sort out the scale. Oops, we'll make the scale 1 on the x-axis, and then we'll overall just bring his scale in a bit. And then his collider we can just modify so that it is like that. I think that works. Can disable that. Okay. So now if we hit the play button, we can see things are looking a little bit better. Okay, obviously the collider on the platform is like way off because it looks like he's jumping from there. So let's just go double check that. Oh, there we go. So the collider on the platform is definitely a bit screwy. So let's just change that to suit the platform a bit more closely. All right. There we go. And that looks a lot better. I mean, better is relative, I know, but it works for now. Okay, so let's one more thing. Let's just bring in the background. So for the background, I'm going to create another UI canvas, and I'm going to call this the background canvas. And this one, I'm going to use screen space, and I'm going to drag in our camera. And then I'm going to create a UI panel, and this is going to be our background panel. And in here, I'm going to bring in our background prefab. Our background sprite, and I'm just going to bring the transparency all the way up to 255. And now when we hit the play button, we can already see it in the scene view, but then we'll have this little background, and the grid shape makes it seem like we're moving, or it makes it easier to see that we're moving up. Cool. And that, everybody, is Jumpy Wumpy. Lots of fun. Thanks so much for watching, and I'll catch you on the next one.